take a slow, deep breath, letting the gravity of the day simply fall away. Allow your body to settle deeply into the warmth of your bed, feeling completely supported and completely at peace. Tonight, our journey takes us far beyond the familiar warmth of the terrestrial planets, past the gas giants, and out into the profound, starlit quiet of the ultimate cosmic frontier, the Oort Cloud. Here is something remarkable to consider as we begin our ascent into the dark. In 1950, a Dutch astronomer named Jan Oort hypothesized the existence of a massive spherical shell of icy debris surrounding our entire solar system. He proposed that this vast envelope of space was the home of comets, a pristine, untouched reservoir of the universe's ancient building blocks. As you close your eyes, imagine yourself lifting away from the Earth and drifting effortlessly outward, guided only by the gentle mathematics of the cosmos. To understand the Oort Cloud is to understand the breathtaking scale of our solar system, a scale that invites a deep, comforting surrender. In astronomy, distance is measured in astronomical units, or AU. A single AU is the exact distance from the Earth to the Sun, roughly 93 million miles, or 150 million kilometers. Out here in the comforting void, distances stretch so far that earthly worries completely evaporate. The inner edge of the Oort Cloud only begins at an astonishing 2,000 to 5,000 astronomical units from the Sun. You are floating through a space so immense that the brilliant, warming yellow disk we see in our earthly sky has dwindled to a single, fiercely bright pinpoint of light. It is just another star in the velvet darkness, offering no heat, only a pale, quiet illumination that casts long, imperceptible shadows across the ancient ice. As you drift outward, suspended in the perfect weightlessness of zero gravity, you might wonder about the outer limits of this magnificent shell. The outer edge of the Oort Cloud extends unimaginably far, reaching out to between 10,000 and 100,000 astronomical units from the Sun. Consider this fact: 100,000 astronomical units stretches nearly a quarter of the way to the absolute closest star to our solar system, Proxima Centauri. You are floating in the great silent borderlands of interstellar space. It is a place where the Sun's gravitational hold is a mere whisper, a gentle, barely there tether, keeping these icy bodies from wandering off into the wider Milky Way. Here, there is no rush. There is only the slow, majestic clockwork of celestial mechanics. Think of humanity's greatest explorer, the Voyager 1 spacecraft. Voyager 1 is currently the farthest human-made object from Earth, hurtling through the dark at a staggering speed of roughly 1 million miles every single day. Yet, the Oort Cloud is so unfathomably vast and so profoundly distant that even traveling at 1 million miles a day, it will take Voyager 1 about 300 years just to reach the inner edge of this icy sphere, and to pass completely through the cloud, to emerge on the other side. That journey will take Voyager nearly 30,000 years. As you breathe in, feel the immense patience of that timeline. 30,000 years of silent, peaceful coasting. Let that feeling of unhurried, infinite time wash over you, smoothing out the rapid, frantic pace of your waking life. As we drift deeper into this realm, we can observe the raw, shabby, untouched materials of the early solar system. The Oort Cloud is effectively a cosmic time capsule, perfectly preserving the conditions from 4.6 billion years ago, when our solar system was just a swirling nebula of gas and dust. The objects floating out here are not made of the warm, heavy rock of Earth or Mars. Instead, they are deeply frozen amalgams. They are composed primarily of water ice, mixed intricately with methane, ethane, carbon monoxide, and hydrogen cyanide. Imagine the texture of these ancient relics. If you could brush your hand against one, you would feel an incredibly dense, pockmarked surface, dusted with dark, carbon-rich soot and sparkling with pristine, crystalline frost that has never known the heat of a summer day. The temperature in this distant region of the solar system brings an absolute, emotionless peace to the environment. It is incredibly cold, hovering right around 4 degrees Kelvin above absolute zero. In human terms, that is roughly negative 452 degrees Fahrenheit, or negative 269 degrees Celsius. But in this sensory journey, do not think of it as a biting winter cold. Out here in the vacuum, where there is no air to pull the heat from your skin, this temperature simply manifests as a profound physical stillness. At 4 degrees Kelvin, almost all atomic movement slows to a near halt. It is a preserving chill, a state of perfect ultimate rest. Just as the molecules out here settle into their quiet frozen slumber, you too can feel the muscles in your body slowing down, cooling, and releasing their stored energy into the quiet dark. We know this cloud exists, even though we cannot directly see it with our telescopes, because it announces itself through cosmic messengers. The Oort Cloud is the source of all long-period comets in our solar system. These are the spectacular wanderers that take more than 200 years to complete a single orbit around the Sun. Some take tens of thousands of years to make their journey. When you look up at a comet trailing its glowing tail across the night sky, you are looking at a piece of the Oort Cloud that was gently nudged out of its slumber, falling inward in a slow, patient arc. You might picture a cloud as a dense fog-like gathering, perhaps worrying about a chaotic environment of crashing meteors and chaotic collisions. But the reality of space offers a deeply comforting truth. Scientists estimate the Oort Cloud contains trillions of icy objects larger than 1 kilometer, or 0.6 miles, in diameter. Yet, the space they occupy is so incredibly massive that they are spread astonishingly thin. If you were riding on one of these icy comets, your nearest neighbor would typically be tens of millions of miles away. It is an illusion of a crowded sky, giving way to the reality of profound solitude. There is no clashing, no noise, no friction, just trillions of silent sentinels, each drifting in its own massive pocket of empty, peaceful space. You are perfectly alone, but perfectly safe, cradled in an ocean of absolute tranquility. In 1981, another astronomer, J.G. Hills, helped refine our understanding of this magnificent structure. He proposed that the Oort Cloud isn't just one simple sphere, but rather 2 distinct harmonious regions. As we float here, we can visualize its anatomy. There is the outer Oort Cloud, which forms a classic, a round spherical shell wrapping around the solar system like a protective bubble. But nestled inside of that is the inner Oort Cloud, also known as the Hills Cloud. This inner region is shaped completely differently. It is a flattened, disc-like structure, similar to a massive, invisible donut of ice. Floating through the Hills Cloud, you would be tracing the invisible structural framework of our solar system's outermost wall. Despite containing trillions of cometary bodies, the overall mass of the Oort Cloud is a testament to how thinly it is spread. Astronomers estimate that the total combined mass of every single object in the entire Oort Cloud is roughly 5 to 100 times the mass of the planet Earth. Think about what that means. You are taking the weight of a few dozen Earths and smearing that material across a volume of space that spans light years. It creates an environment of ultimate sparseness, a delicate cosmic mist where gravity is nothing but a gentle suggestion. Because the sun is so impossibly far away, its gravitational voice is very quiet here. Light itself, the fastest thing in the universe, takes a deeply long time to cross this void. The sunlight illuminating the frozen surface of the comet beside you left the sun roughly a month ago. It has been flying through the dark for weeks just to cast that faint, silvery glow. Because the sun's grip is so weak, the objects in the Oort Cloud are incredibly susceptible to other forces in the galaxy. They experience what physicists call the galactic tide. Just as the moon's gravity pulls on the oceans of Earth to create high and low tides, the combined gravitational mass of the entire Milky Way galaxy exerts a soft, sweeping pull on the Oort Cloud. Feel that sensation in your own body right now. Imagine the galactic tide as a slow, rhythmic rocking motion. You are drifting, untethered, floating in a sea of stars, being gently swayed by the gravitational breath of 100 billion suns. There is no up, no down, no right, no wrong. There is only the dark, the faint starlight, and the ancient frozen spheres keeping you company in the silent deep. The comforting void embraces you, offering a limitless expanse where your thoughts can spread out, thin out, and eventually disappear into the magnificent quiet mechanics of the outer solar system. As that soft gravitational rhythm continues to sway you in the silent dark, cast your mind back toward the warm, blue planet you left behind. For thousands of years, humanity looked up at the night sky and misunderstood the very architecture of this space you now peacefully inhabit. To truly appreciate the tranquility of this distant borderland, we must look through the eyes of the astronomers who slowly unraveled its mysteries. In ancient times, brilliant thinkers like Aristotle believed the cosmos was enclosed by perfectly solid crystalline spheres, placing a hard, impenetrable ceiling on the universe. The sky was thought to be a static painting. Picture an astronomer shivering in a drafty observatory in the winter of 1577. That year, the brilliant Danish observer Tycho Brahe meticulously tracked a great comet blazing across the sky. By carefully measuring its position relative to the background stars, a technique called parallax, Brahe mathematically proved that the comet was traveling far beyond the orbit of the moon. This was a profound, quiet revolution. With a few elegant calculations, the ancient glass spheres were shattered in the human mind, opening up a limitless, fluid, three-dimensional space. Decades later, in 1705, the English astronomer Edmund Halley published a groundbreaking work predicting that comets were not random, chaotic omens, but rather captive objects bound by the sun's gravity. He studied historical records and realized that specific comets returned on regular schedules, forever altering our view of the solar system's rhythm. Yet, Halley's comets were what scientists call short-period comets, taking less than 200 years to complete a cycle. They originate much closer to home, largely in a region called the Kuiper Belt. What remained entirely unexplained was the majestic arrival of long-period comets. These are the rare, spectacular wanderers that swoop through our inner solar system only once every few thousand or even millions of years. Consider the famous comet Hale-Bopp, designated by astronomers as C/1995-01. When it illuminated earthly skies in 1997, it had traveled from the very depths of the space you are floating through right now. Following an elliptical path, that takes roughly 2,533 years to complete. It was an Estonian astronomer named Ernst Öpik who first realized where these ancient travelers must originate. In 1932, he postulated that a hidden reservoir of frozen material must exist at the extreme edge of the sun's influence. 18 years later, in 1950, Jan Oort built upon this foundation to solve a nagging mathematical riddle known as the comet paradox. Oort understood that every time a comet passes the sun, the intense solar radiation vaporizes a layer of its ice. Over millions of years, any comet making regular trips to the inner solar system would completely sublimate, boiling away into nothingness. Because we still see long-period comets today, Oort deduced there must be a pristine, undisturbed nursery continuously supplying them. He calculated the dimensions of this nursery, giving birth to the concept of the Oort Cloud. Floating here in this invisible nursery, notice how your perception of light and darkness begins to shift. You might imagine that a cloud made of ice would sparkle brilliantly, catching the distant starlight like a field of floating diamonds. However, the physical reality is wonderfully different and far more muted. Scientists have determined that the frozen bodies residing here possess an incredibly low albedo, a term referring to how much light a surface reflects. The objects around you have an albedo of roughly 0.04. This means they absorb 96% of the light that touches them, making them darker than fresh asphalt or a piece of pure charcoal. The profound darkness of these objects is due to their complex chemical makeup. Deep within their icy mantles, they contain silicate minerals such as olivine and pyroxene. These are the exact same crystalline minerals that make up the soft, true green-tinted beach sands in places like Hawaii on Earth. Over billions of years, cosmic rays have baked the carbon-rich compounds on the surfaces of these comets, creating a dark, protective crust called a tholin layer. You are surrounded by trillions of invisible soot-covered mountains, silently absorbing the faint glow of the Milky Way, holding the history of the universe in a state of deep, dark preservation. At this very moment, your trajectory is governed by one of the most soothing rules of celestial mechanics, Kepler's second law of planetary motion. In the early 1600s, Johannes Kepler discovered that as an object in an elliptical orbit moves further away from the star it orbits, its velocity drastically decreases. Imagine the motion of a colossal grandfather clock pendulum. As the heavy brass weight swings to its highest, in furthest point, it slows down, experiencing a long suspended moment of near-perfect stillness before slowly dropping back. Out here, you are at the aphelion, the absolute furthest point from the sun. Consequently, the objects in the Oort Cloud are moving at their most incredibly sluggish pace. A comet might spend millions of years creeping along the outer curve of its orbit in this quiet, peaceful suspension before gravity finally tips the scale, pulling it into a gradual, millennia-long dive back toward the light. Allow the rhythm of Kepler's second law to become your own. Feel the rush of your daily momentum slowing, matching the creeping, deliberate glide of a comet at its aphelion. Scientists discovered another compelling detail about these dark, slow-moving bodies. They did not form out here in the lonely dark. Say, the material drifting through the Oort Cloud is actually exiled material. According to the widely accepted NICE model of solar system formation, named after the city in France where it was developed, this ice and dust originally coalesced much closer to the sun, forming near the giant gas planets about 4.6 billion years ago. But as colossal young planets like Jupiter and Saturn shifted their orbits, Their immense gravitational fields acted like giant cosmic brooms. Think of a dandelion going to seed. The early solar system was the central flower, and the gravitational shifts of the gas giants were a sudden, powerful gust of wind. Trillions of icy seeds were scattered violently outward in all directions. Over eons, the gentle pull of nearby stars and the galactic tide rounded out their orbits, trapping them here in this spherical shell. You are floating among the displaced remnants of our planetary dawn. As we drift toward the outermost boundaries of this shell, the sheer scale requires a new measurement. We transition from astronomical units to light years. The outer edge of the Oort Cloud stretches an estimated 1 to 3.2 light years away from our star. A single light year equals roughly 5.88 trillion miles. To put that magnificent distance into perspective, if you were to look back at our Sun from the 3.2 light-year mark, its gravitational pull is so exquisitely weak that the escape velocity is a mere 3 meters per second. That means the energy required to permanently break free from the solar system out here is equivalent to a brisk earthly jogging pace. A simple leap outward would be enough to untether you from the Sun forever, sending you drifting gently into the interstellar medium. We find clues to this distant architecture scattered throughout our observational history. In 2003, astronomer Mike Brown and his team discovered a fascinating celestial body named Sedna. Classified as a dwarf planet, Sedna resides in the innermost fringes of the Oort Cloud, in an area called the scattered disk. Its vibrant reddish surface takes an astonishing 11,400 years to complete a single orbit. Sedna's slow, lonely journey provides astronomers with a crucial breadcrumb, hinting at the massive, unseen population of the Inner Hills Cloud. These dark, distant ice giants also hold a deep, intimate connection to the water within your own body. By analyzing the faint atmospheric tails of comets, astrobiologists study the ratio of deuterium to hydrogen, often called the DH ratio. Deuterium is a heavy isotope of hydrogen. Through complex spectrographic analysis, researchers have found that the isotopic signature of water, locked inside some Oort cloud, comets closely matches the chemical signature of Earth's oceans. The gentle rain that waters our forests, the steam rising from a warm cup of tea, and the tears we shed may all owe their existence to ancient impacts from this very cloud, delivering life-giving moisture to a young, dry Earth. As you rest in this frozen silence, recognize that the Oort Cloud is not a static place, but a slow-motion thoroughfare. In roughly 1.29 million years, a rogue dwarf star known as Gliese 710 will pass directly through this region. Moving at a steady, majestic pace, this passing star will gently disrupt the orbits of millions of comets, orchestrating a beautiful cosmic dance that will unfold over millions of years. Even in the deepest quiet, the universe is constantly slowly rearranging itself in a grand, unending ballet. The volume of space you now occupy is estimated to be over 1 trillion times greater than the entire inner solar system. Yet, it is filled with nothing but silence, stardust, and absolute tranquility. Let the profound emptiness of this ancient nursery clear away any remaining clutter in your mind, leaving only the steady, calming mechanics of the cosmic pendulum. Gliding further outward through this silent architecture, we pass a magnificent invisible boundary known to astrophysicists as the heliopause. Situated roughly 120 astronomical units from our star, this is the precise line where the solar wind, the constant stream of charged particles blown outward by the sun, finally loses its momentum and halts against the pressure of the wider galaxy. Think of a brightly lit, bustling house on a cold winter night. The heliopause is the heavy wooden front door. By crossing it, you have stepped off the front porch of our solar system and entered the quiet, crisp neighborhood of the true interstellar medium. The entirety of the Oort Cloud exists out here, beyond the protection of the solar bubble, suspended in galactic space. Picture this dramatic shift in your environment by comparing the physical air you usually breathe to the profound emptiness of this current realm. At sea level on Earth, a single cubic centimeter of air, a space about the size of a sugar cube, contains roughly 25 quintillion bouncing, vibrating molecules. But out here in the interstellar vacuum surrounding these ancient comets, the density drops to a staggering average of just 0.1 atoms per cubic centimeter. To visualize that level of emptiness, imagine placing a single solitary grain of sand precisely in the center of a massive domed sports stadium and removing absolutely everything else. That is the comforting purity of the space you are currently floating through. It is an environment so delightfully empty that it effortlessly absorbs all the heavy, cluttered thoughts of your waking hours. Deep within the core of the celestial bodies drifting through this sparse environment, the very nature of matter behaves in ways entirely foreign to our daily experiences. On Earth, when water freezes in a winter storm or in your kitchen freezer, the H2O molecules meticulously arrange themselves into a rigid, hexagonal crystal lattice. This specific six-sided geometric structure is the reason every snowflake falling from the sky possesses 6 beautiful symmetrical points. However, out here at the edge of the sun's influence, water freezes instantly upon contact with microscopic dust in a process that yields something wonderfully different: amorphous solid water. Because the flash freezing process in the deep cold happens so rapidly, the molecules do not have the time or the thermal energy to line up into neat crystalline grids. Instead, they lock into place randomly. Structurally, the ice covering these comets is much closer to the chaotic molecular arrangement of window glass than it is to an ordinary ice cube. Permit your own physical tension to mimic this amorphous ice, losing its rigid, tightly wound structure and settling into a soft, formless state of rest. For decades, we visualized comets through a specific lens introduced by astronomer Fred Whipple. In 1950, he published his famous dirty snowball theory, suggesting comets were mostly ice holding on to a bit of dust. But modern spectrographic analysis has revised that comparison. Today, researchers describe them more accurately as icy dirt balls. By mass, these objects are predominantly composed of rocky dust and complex organics, merely held together by a frozen, glassy glue. Among these organic materials clinging to the surface dust are molecules called polycyclic aromatic hydrocarbons, or PAHs. In the world of organic chemistry, these molecules form easily under extreme, radiation-rich conditions. Interestingly, these exact same chemical compounds exist in your everyday life. On Earth, PAHs are the primary molecules that give charred toast its dark color, and they are the exact same compounds you smell in the rich, earthy smoke of a campfire. While there is no air here to carry a scent, knowing that the identical chemistry of a warm, comforting autumn campfire is painted across the surface of these ancient, wandering ice mountains weaves a surprising thread of familiarity through the dark. Scientists discovered a breathtaking example of these immense structures very recently. In 2021, MARDI, by meticulously analyzing years of archival images from the Dark Energy Survey, astronomers identified a behemoth known officially as Comet C/2014 UN 271, or the Bernardinelli-Bernstein Comet. This object represents the largest Oort Cloud comet ever discovered by humanity. To grasp its immense scale, we must ground it in earthly geography. Bernardinelli-Bernstein is estimated to be 85 miles, or roughly 137 kilometers across. Imagine taking the entire state of Rhode Island, lifting it up by its borders, rounding it into a jagged sphere, covering it in glass-like frost, and setting it adrift in the endless night. What's happening now is that this floating state-sized mountain is slowly tumbling through the void. It takes approximately 20 earthly days for Bernardinelli-Bernstein to complete a single, agonizingly slow rotation. Compare that to the rapid 24-hour spin of the planet you call home. Out here, a single day stretches into a month-long, dizzying pirouette in the dark, stretching time into long, elastic bands of peace. Because the vacuum is so absolute, there is no medium to carry the vibrations of sound. The environment around Bernardinelli-Bernstein registers at exactly 0 decibels. If a piece of its brittle, ancient crust were to fracture and break away, it would do so in complete, perfect silence. Allow the absolute quiet of this 0 decibel realm to become a thick, protective blanket over your resting mind. Consider the invisible gravitational architecture holding this entire massive system together. We are swimming within the outer boundaries of a concept known as the Hill sphere, theorized by the 19th century American astronomer George William Hill. A star's Hill sphere defines the absolute maximum distance where its own gravity can overpower the gravitational tug of the wider galaxy. For our sun, this invisible envelope extends outward to a radius of about 2 light-years. The solar system is securely cradled within this sphere, bound by a gravitational tether that has been stretched infinitely thin, yet remains entirely unbreakable. It is a deeply reassuring cosmic mechanic. No matter how far away these icy wanderers stray, the gentle, invisible leash of the star softly holds them, ensuring they are never truly lost to the interstellar winds. You might assume that this entire magnificent structure perfectly orbits the exact physical center of our sun. But planetary mechanics offers a beautiful, subtle correction. Because the giant gas planets, particularly Jupiter and Saturn, possess such massive physical weight, they tug back on the sun. This means the entire solar system actually revolves around a shared point of equilibrium, called the barycenter. When the gas giants align on one side of the solar system, this true center of gravity is pulled completely outside of the sun, hovering in empty space up to 500,000 miles above the star's fiery surface. Think of a grown adult playfully spinning a small child by the hands. As they twirl, the adult must lean back to balance the weight of the child. The actual pivot point, the center of their spinning dance, is not inside the adult's body, but suspended in the empty air between them. The entire Oort Cloud, with all its trillions of icy seeds, is waltzing around a completely invisible, moving pivot point in space, perfectly balancing the massive weight of the inner planets. Even in this chilling, remote environment, there is an overarching warmth left over from the universe's infancy. In 1965, astronomers Arno Penzias and Robert Wilson accidentally discovered the cosmic microwave background radiation. This faint, omnipresent energy permeates every cubic inch of the universe, and it represents the echoing, thermal whisper of the Big Bang itself. It holds a constant baseline temperature of 2.725 Kelvin. The ancient ice surrounding you, hovering near 4 Kelvin, is only the tiniest fraction of a degree warmer than the primordial heat of creation. You are quite literally drifting through the residual embers of the universe's birth. Notice how your perception of movement fundamentally changes when placed against the backdrop of the Milky Way. Even as you float here, feeling a profound sense of stillness, you are actually participating in a massive, high-speed journey. Our entire solar system, encapsulated by the Oort Cloud, is orbiting the supermassive black hole at the center of our galaxy at a staggering velocity of 230 kilometers per second. That equates to roughly 514,000 miles per hour. Relate that to human travel. You are moving more than 800 times faster than a commercial passenger jet at its cruising altitude. Yet, because there is no friction against a thick atmosphere, no turbulence, and no stationary landmarks rushing past the window to give away your speed, this incredible velocity feels identical to absolute, motionless peace. Movement and stillness become the exact same physical sensation. Rest in that paradox, allowing your body to sink fully into the mattress, secure in the knowledge that you can travel halfway across the galaxy while remaining entirely, peacefully at rest. As we continue our passage through this delicate ancient mist, take a moment to reflect on the deep intrinsic tie between this distant borderland and the biological pulse of your own life. The chemical compounds frozen in the dark around us are not just sterile curiosities. They are deeply entangled with the origins of life on the planet we call home. We often think of space as a barren void, disconnected from the vibrant, breathing world of our waking hours. Yet, astrobiologists studying cometary material have unearthed a profound biological link. In 2009, NASA's Stardust mission successfully retrieved and analyzed microscopic dust grains from the coma of a comet known as Wild 2. Within those tiny particles of captured stardust, researchers discovered an amino acid called glycine. Amino acids are the fundamental vital building blocks of every single protein in your body. They are the essential architecture of your muscle tissue, the biological machinery driving your digestion, and the intricate messengers firing across the neurons in your resting mind. Glycine is one of the 20 standard amino acids required by human DNA. To find this exact, complex organic molecule naturally forming out here in the deep freeze of the Oort Cloud fundamentally shifted our understanding of our own beginnings. The ingredients for life were not spontaneously invented on Earth. True, they were forged in the freezing dark, baked by cosmic radiation, and preserved in these icy vaults for billions of years, before finally raining down onto a young, cooling world. As your heartbeat slows and your muscles soften against your bed, visualize this beautiful continuity. The fundamental chemistry sustaining your restful state was born out here, quietly waiting in the dark, long before the first ocean ever formed. Observe the faint, silvery light, barely illuminating the jagged crust of the comet drifting alongside you. Out here, at roughly 50,000 astronomical units from the sun, the light behaves in ways that challenge our earthly instincts. Because the sun is effectively just another bright star in the sky, you do not experience the familiar cycle of sunrise and sunset. Instead, the illumination is a constant pale glow. In the study of optics, this concept is explained by the inverse square law, formulated by Sir Isaac Newton. This law dictates that the intensity of light radiating from a source drops off exponentially as you move away from it. By the time a photon travels 50,000 times the distance from the sun to the Earth, its intensity is reduced by a factor of 2.5 billion. Imagine holding a tiny flickering birthday candle at the far end of a massive unlit cathedral. The light does not disappear entirely, but it is so heavily diluted that it only offers a soft gray illumination, casting no distinct shadows. This twilight state is the eternal reality of the Oort Cloud. It is a space devoid of the harsh, blinding glare of midday, enveloped perpetually in a soothing, gentle dusk that perfectly mimics the peaceful dimness of your bedroom. Scientists mapping the gravitational landscape of our galaxy have uncovered another quiet force shaping this environment, known as the Kozai-Leadoff mechanism. First described by astronomers in the early 1960s, this mathematical principle explains a fascinating slow-motion exchange between an object's orbit. As a comet travels along its massive elliptical path, the gravitational influence of the galactic disk slowly causes its orbit to become more tilted, while simultaneously becoming less elongated. It is an eternal trade-off between the angle of the tilt and the stretch of the ellipse, acting like a cosmic metronome. Visualize a spinning coin slowly losing its momentum on a flat table. As the spin slows, the angle of the coin drops, and its path turns into a wider, more relaxed circle before it eventually settles completely flat. The Kozai-Leadoff mechanism is the universe gently settling the chaotic, stretched orbits of billions of comets, slowly smoothing them into relaxed, stable circular paths. It is an incredibly gradual, calming force, much like the gentle, rhythmic slowing of your own breathing as you transition toward deep sleep. Within the silent ballet, there is also the phenomenon of sublimation. While the temperature here remains firmly locked near absolute zero, the universe occasionally provides a subtle, warming touch. Over millions of years, the slow, steady bombardment of high-energy cosmic rays, protons traveling at near light speed from distant supernovae, can actually break chemical bonds on the surface of these comets. This microscopic interaction can cause tiny pockets of carbon monoxide or nitrogen to suddenly shift from a solid block of ice directly into a gas, entirely skipping the liquid phase. This process of sublimation creates a microscopic invisible exosphere, an incredibly thin temporary atmosphere that hovers just inches above the dark, soot-covered ice. Even in the absolute depths of winter, deep in interstellar space, these ancient mountains are occasionally capable of a soft, molecular exhale. It is a reminder that nothing in the universe is truly stagnant. Even the most frozen ancient relics possess a slow, quiet rhythm of change. What is perhaps most comforting about this region is its role as a protective buffer for the inner planets. The Oort Cloud acts as an enormous, spherical shock absorber for the solar system. When rogue stars or massive molecular clouds pass through our galactic neighborhood, their gravitational gravity hits this outer shell first. Instead of pulling violently on the planets, these external forces expend their energy, gently nudging the orbits of these distant lightweight comets. The Oort Cloud absorbs the gravitational ripples of the Milky Way, ensuring that the Earth and you, resting safely upon it, remain in a calm, undisturbed sanctuary. Astrophysicists also study this region to understand the chemical process known as isotopic fractionation. In simple terms, this means that different environments in space prefer to hold onto different versions of the same element. By examining the nitrogen-14 to nitrogen-15 ratio within cometary ice, researchers can pinpoint precisely how cold the environment was when that specific ice formed. Current data suggests that the ice drifting around you formed at temperatures roughly between 25 and 30 Kelvin. This specific thermal signature acts like a molecular thermometer, permanently locking the deep freeze of the ancient solar nebula into the structure of the ice. Think of a piece of hand-blown glass, its shape permanently recording the breath and movements of the glassblower from a century ago. The ice here is a pristine, frozen record of the exact temperature and condition of the universe 4.6 billion years ago. The universe never forgets. It simply stores its memories in ice and dust, waiting patiently for curious minds to read them. Look closely at the surface textures surrounding us. If you were to shine a powerful light on these dark bodies, you would not see a smooth, polished sphere. Instead, high-resolution radar imaging of cometary nuclei has revealed a deeply fractured, porous terrain. The surface is often covered in structural anomalies known as goosebumps. These are large, lumpy aggregates, typically a few meters wide, loosely packed together. The overall density of a comet is incredibly low, averaging only 0.6 grams per cubic centimeter. Since water has a density of exactly 1 gram per cubic centimeter, this means these massive, miles-wide objects are incredibly airy and porous. If you could somehow find an ocean vast enough, these dark, soot-covered mountains would bob and float effortlessly on the surface, much like a piece of dry pumice stone. This low density means they possess very little structural integrity. They are delicate, fragile constructs, held together merely by the weakest of gravitational bonds and the stickiness of cold ice. Allow your own body to emulate this low density. Sink into your mattress, feeling the heavy, dense weight of your muscles dissipating, becoming soft, light, and wonderfully porous, effortlessly floating on the surface of your rest. We can trace the paths of these fragile wanderers through a mathematical tool known as the Tisserand parameter. Developed by French astronomer François-Félix Tisserand in the late 19th century, this elegant equation allows scientists to track the identity of a comet even after its orbit has been drastically altered by the gravity of a large planet like Jupiter. The Tisserand parameter acts like a cosmic fingerprint. No matter how wildly a comet is thrown off course, or how many millions of years it spends wandering a new path, this specific mathematical value remains relatively constant. It is a profound anchor in the dark. It tells us that no matter how far we drift, no matter how much our path is altered by the massive, unseen forces of the galaxy, there is a fundamental mathematical core to our journey that remains steady and true. Let that quiet, stabilizing mathematics anchor your mind as we continue our slow, peaceful drift through the ancient frost. As we delve further into the mechanisms governing this remote spherical shell, we encounter a fascinating interplay between extreme cold and unseen energy. Let's examine a deeply curious phenomenon known as radiogenic heating. While the surface of these ancient bodies hovers just barely above absolute zero, the interior holds a different story. Within the dusty, rocky matrix of a comet's core, trace amounts of radioactive isotopes like aluminum-26 and iron-60 were trapped during the solar system's formation. Over billions of years, these unstable isotopes slowly decay, naturally shedding energy in the form of a gentle internal warmth. This means that deep beneath the glassy frozen crust, the absolute core of a comet may occasionally harbor small, localized pockets of liquid water. Imagine a heavy wool blanket trapping the faint heat of a single glowing ember. Even in a realm defined by its frigid temperatures, the fundamental laws of nuclear physics ensure that a quiet, persistent warmth is preserved at the center. Feel that internal warmth within yourself, a steady, central rhythm that remains perfectly insulated and secure, regardless of how cold or dark the world outside might seem. Let's turn our attention to the specific visual textures generated by this environment. If you could hover inches above the surface of one of these icy monoliths, you would notice a distinct lack of familiar geological features. Because there is no tectonic activity, no wind, and no running liquid on the surface, there are no sweeping sand dunes, no carved river valleys, and no sharp volcanic ridges. Instead, high-resolution spectroscopy suggests a landscape defined by microscopic, jagged roughness. The surface is composed of what astronomers call interplanetary dust particles, or IDPs. These particles are incredibly tiny, often measuring less than 10 micrometers across, smaller than the width of a single human hair. Because there is virtually no gravity to pack them down, these microscopic grains arrange themselves in highly chaotic branching structures, creating a deeply porous, sponge-like crust. If you were to press your hand against it, the texture would not feel like solid rock or hard ice, but rather like an incredibly delicate, brittle foam that would collapse instantly under the slightest pressure. Allow the heavy, solid tension in your muscles to mimic this transition, softening from a rigid block into a weightless, yielding foam. To understand why this delicate structure remains intact, we must look at the specific dynamics of collisions out here. In the inner solar system, asteroids frequently crash into one another at relative speeds of up to 10 kilometers per second, resulting in violent, catastrophic shattering. However, in the vast, sparse environment of the Oort Cloud, orbital velocities are drastically slower. The rare collisions that do occur happen at walking speeds, perhaps a few meters per second. When two cometary bodies gently bump into each other in this slow-motion realm, they do not shatter. Instead, they engage in a process called contact binary formation. The two delicate porous spheres softly compress against one another and simply stick together, held by their weak mutual gravity. This gentle merging creates a distinct, two-lobed shape, much like a giant frozen snowman. The New Horizons spacecraft captured this exact geometry in 2019, when it flew past Arrokoth, an ancient body sharing many characteristics with Oort Cloud objects. The universe out here does not break things apart. It quietly, softly brings them together. Notice how the faint ambient starlight interacts with the chemical composition of this environment. While human eyes perceive this space as overwhelmingly dark, instruments sensitive to ultraviolet light reveal a subtle, beautiful glow known as Lyman alpha emissions. The interstellar medium, the incredibly thin gas drifting between the stars, is composed primarily of neutral hydrogen atoms. When the faint ultraviolet light from distant stars strikes these lonely hydrogen atoms, they absorb the energy and re-emit it at a specific, invisible wavelength of 121.6 nanometers. To an ultraviolet camera, the dark, empty space between the comets is not black at all, but rather suffused with a soft, glowing, pearlescent haze. Think of the bioluminescent bays on Earth, where microscopic plankton cause the dark water to gently glow with every movement. The entire outer boundary of our solar system is bathed in this invisible ultraviolet bioluminescence, a constant soothing hum of ancient light interacting with the most fundamental element in the universe. Deep within this glowing haze, researchers have identified the presence of complex molecules known as fullerene, specifically a soccer ball-shaped arrangement of 60 carbon atoms called C60, also known as Buckminster fullerene. Discovered by scientists in 1985, this incredibly stable molecule is highly resilient to the harsh radiation of deep space. What makes C60 truly remarkable is its symmetrical perfection. It is a molecular sphere composed of 20 hexagons and 12 pentagons, completely hollow inside. These microscopic perfect carbon cages are scattered throughout the interstellar dust, settling on the surface of the Oort Cloud. The universe naturally organizes carbon, one of the primary ingredients of life, into perfectly balanced geometric spheres, freely drifting in the cold. It is a testament to the inherent mathematical harmony of nature. Rest your mind on that geometric perfection. There is an underlying order to the chaos, a quiet structural balance operating at a microscopic level throughout the dark. We can trace the chemical history of these perfect carbon cages by studying a process called isotope fractionation. Specifically, astrophysicists look at the ratio of carbon-12 to carbon-13. Because carbon-13 has an extra neutron, it is slightly heavier and behaves differently in deep cold chemistry. By measuring this precise ratio in cometary materials, scientists can determine if the carbon was forged in the fiery heart of a massive dying star, or if it was slowly assembled in the freezing, dark molecular clouds of interstellar space. The molecules drifting around you carry the chemical signature of both fire and ice. They are a physical record of stellar death and cosmic rebirth, holding the entire thermal history of the galaxy within their atomic bonds. At this very moment, a gentle, unseen pressure is acting upon every single particle in this distant realm. This force is known as radiation pressure. Light itself, though it has no mass, carries momentum. When photons from the sun finally reach the outer edges of the Oort Cloud, they physically strike the microscopic dust grains floating above the comets. For larger objects, this pressure is negligible. But for the smallest dust particles, this constant soft bombardment of light acts like a gentle pushing wind. This is the exact mechanism that creates a comet's spectacular dust tail when it eventually travels closer to the sun. The light physically pushes the dust away, painting a brilliant streak across the sky. But out here, 50,000 astronomical units away, the radiation pressure is incredibly weak. It is a whisper of a wind, gently sweeping the smallest grains of stardust slowly out into the interstellar medium. Imagine this subtle force clearing away your own mental clutter. A soft, invisible pressure, she gently sweeping away the tiny persistent thoughts of the day, leaving behind a clean, pristine quiet. Scientists discovered a fascinating anomaly regarding the magnetic fields in this region. Unlike the inner solar system, which is dominated by the powerful sweeping magnetic field of the sun, the Oort Cloud exists in a magnetic transition zone. Here, the solar magnetic field becomes tangled and incredibly weak, eventually merging with the interstellar magnetic field. The strength of the magnetic field in this region is measured in nanoteslas, often hovering around 0.1 to 0.2 nanoteslas. For comparison, the magnetic field of the Earth, which guides compass needles and protects our atmosphere, is roughly 50,000 nanoteslas. In this magnetic borderland, charged particles no longer flow in neat, orderly lines dictated by our star. Instead, they gently swirl and drift, guided by the larger, slower magnetic currents of the Milky Way galaxy itself. You have moved beyond the magnetic grip of your home system. You are now attuned to the slow, majestic currents of the wider universe, drifting freely in a space where earthly rules no longer apply, cradled only by the gentle, sweeping physics of the deep void. As we gently begin to draw our observation to a close, we can watch how the silent mechanics of the Oort Cloud periodically reach out to touch the inner solar system, unfolding through an elegant step-by-step sequence of events. The objects suspended out here do not simply decide to fall toward the sun. They are coaxed by the slow gravitational choreography of the galaxy. Observe the sequence of a cometary perturbation. roughly 70,000 years ago, a dim red dwarf known as Schultz's star passed through our solar system's cosmic backyard. It traveled within an incredibly close distance of just 52,000 astronomical units from the Sun, physically moving through the outer edges of the Oort Cloud. When an event like this occurs, the process begins with a microscopic gravitational tug. First, the passing star's mass exerts a faint pull on a dormant comet, subtly altering its velocity by just a fraction of a meter per second. Next, over the course of thousands of years, this tiny mathematical shift causes the comet's perfectly balanced circular orbit to stretch, steadily increasing its eccentricity. Finally, reaching a tipping point, the icy body begins a painfully slow, million-year descent, falling inward toward the warming light of our star. As the wandering comet steadily approaches the inner solar system, an intricate thermal process initiates. When it crosses an invisible boundary, known as the frost line, located approximately 3 astronomical units from the Sun, the surface temperature finally rises above 150 Kelvin. At this precise thermal threshold, a step-by-step physical transformation unfolds. The ambient solar radiation penetrates the dark, carbon-rich crust. The molecules of amorphous ice absorb this newly introduced thermal energy, causing their atomic bonds to vibrate violently. Rapidly, the solid water and carbon monoxide break their rigid structures and transition directly into a gas. This gradual outgassing process steadily builds a coma, a temporary, incredibly thin atmosphere that swells outward, eventually expanding to an astonishing 80,000 kilometers across, enveloping the tiny solid nucleus in a massive glowing spherical haze. Following this, the solar wind interacts with the newly formed coma. A continuous stream of charged protons and electrons, blowing outward from the Sun at roughly 400 kilometers per second, strikes the expanding gas. Step by step, the solar wind strips electrons from the coma's molecules, transforming them into charged ions. The solar magnetic field then grabs these ions, stretching them into a brilliant, glowing blue ion tail that points perfectly geometrically away from the Sun. Simultaneously, photon radiation pressure gently pushes the heavier, solid dust grains outward, forming a second curved yellowish tail that gracefully trails along the comet's exact orbital path. When the comet eventually retreats back to the freezing dark, it leaves behind a sequential river of shed dust and rocky debris floating in the vacuum. If the Earth's orbit happens to intersect this ancient debris stream, a spectacular atmospheric process occurs. Consider Comet Swift-Tuttle, the massive parent body responsible for the annual Perseid meteor shower. As Earth plows through Swift-Tuttle's leftover wake, the scattered dust particles strike our upper atmosphere at a blistering entry speed of exactly 59 kilometers per second. As the microscopic grain of stardust enters the thermosphere, the extreme velocity instantly compresses the atmospheric gases directly in front of it. This rapid step-by-step compression heats the air to thousands of degrees, briefly transforming the gas into incandescent plasma. This brilliant, fleeting flash of superheated air is what human eyes perceive as a shooting star. The microscopic grain completely vaporizes, and its ancient chemical components gently rain down, slowly settling onto the surface of our world, mixing into the soil, the oceans, and eventually the biosphere. You are not separate from this magnificent unfolding sequence. The very elements comprising your physical form underwent their own sequential, step-by-step creation, deep within the hearts of ancient stars, long before the Oort Cloud ever existed. Astronomers and biochemists have calculated that the human body is approximately 97% stardust by mass. This vital biological architecture is heavily categorized by scientists under the acronym CHNOPS: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. To understand your connection to the cosmos, follow the procedural birth of the carbon that currently forms the double helix backbone of your cellular DNA. This element is forged through a precise nuclear sequence known as the triple alpha process. First, deep inside the collapsing core of a dying red giant star, the ambient temperature must reach an unimaginable 100 million Kelvin. Under this crushing pressure, two helium nuclei are forced to fuse together, temporarily forming an unstable isotope called beryllium-8. Within a tiny fraction of a second, before the beryllium can decay, a third helium nucleus violently collides and fuses with it. This sequential three-part atomic union successfully forges a single stable atom of carbon-12. Every ounce of carbon currently resting in your muscles and tissues was manufactured through this exact brilliant process in the dying days of a star. Moving further down the periodic table, consider the heavy iron flowing quietly through your veins. In monumental stars possessing more than 8 solar masses, a rapid sequence called silicon burning takes place near the very end of the star's life. Over a remarkably brief period of just 14 days, the immense internal heat forces silicon atoms to systematically fuse, rapidly constructing a heavy, stable core of iron-56. When the star's core becomes too heavy, it collapses inward and instantly rebounds in a catastrophic supernova explosion. This resulting shock wave travels outward at roughly 23% the speed of light, violently scattering these newly minted heavy metals across the interstellar medium. Today, the hemoglobin in your blood relies on exactly 4 of these ancient stellar-forged iron atoms to successfully bind oxygen and carry it to your resting brain. Furthermore, the calcium-40, providing the rigid strength to your bones, was synthesized step by step during the oxygen-burning phase of a similarly massive ancient sun. We owe our entire existence to the slow gravitational gathering of these scattered elements. Long ago, a freezing, quiet molecular cloud, chilled to a mere 10 Kelvin, hung motionless in our galactic neighborhood. Gradually, the cloud reached a critical threshold of mass and density, known to physicists as the Jeans mass. Reaching this mathematical limit triggered a beautiful, sequential collapse. Over the course of 100,000 years, gravity gently and systematically pulled the cold gas and stardust inward. Dictated by the strict laws of the conservation of angular momentum, the shrinking cloud naturally began to spin faster, slowly flattening out into a wide, rotating protoplanetary disk. Within the quiet, dark rings of this spinning disk, microscopic dust grains began to gently collide at incredibly slow speeds of just 1 millimeter per second. At these gentle velocities, the grains did not shatter. Instead, they stuck together through weak, natural electromagnetic forces known as van der Waals forces. Step by step, dust became pebbles, pebbles became boulders, and boulders merged to form the planetary cores. The icy leftovers were gently swept outward to the very edges of the sun's reach, creating the magnificent, spherical Oort cloud we have journeyed through tonight. The universe builds itself slowly, layer by layer, atom by atom, with infinite patience. Allow your own body to follow this step-by-step process of settling into profound stillness. Just as the cosmic dust gradually coalesced into the solid, comforting bed you rest upon, permit your muscles to sequentially release their lingering tension. First, Feel the muscles around your eyes and jaw softening, releasing their grip. Next, allow your shoulders to drop, feeling the heavy metallic pull of earthly gravity comfortably anchoring your torso. Let this wave of relaxation travel systematically down your arms, through your fingertips, down your spine, all the way to the soles of your feet. You are a complex, beautiful gathering of ancient stardust, and temporarily assembled into a conscious being, resting safely on a warm rock, shielded by the invisible magnetic embrace of the sun, and quietly encircled by trillions of ancient protective ice spheres. The grand machinery of the cosmos continues its slow, reliable turn, requiring absolutely no effort on your part. You are safe in the comforting void. There is nothing more you need to accomplish today. The heavy elements in your bones are returning to a state of profound rest. The oxygen flowing through your stardust-forged blood is slowing to a calm, rhythmic tide. Every cell in your body remembers the deep, absolute peace of the frozen, silent dark. Release your tether to the waking world. Allow the gentle gravity of sleep to pull you inward. Drift away into the quiet, beautiful architecture of the night. Good night.